All right, the famous yo-yo problem. This is the yo-yo. Do you hyphenate yo-yo? I just don't know. He was a yo-yo. Okay, so this one, basically this thing is going to descend and rotate. There's a string wrapped around a little shaft here, okay? And we're going to neglect the mass of the shaft, which is reasonable because it's going to be very, very small. Its contribution to the moment of inertia is small. And we'll assume that the rest of the yo-yo is a cylinder, okay? And I know that there's two cylinders. We're just going to add the mass of it together, right? So I'm going to ignore the mass of that shaft. That's a massless shaft. There we go. We're ignoring the mass, right? We want to find the acceleration of the system. So let's do it. All right, let's see. So this just has a tension in it, right? Notice that it's not wrapped at the edge of the cylinder. It's wrapped at the smaller radius, which is R2. And then this guy's R1. Evidently my 1 sort of fell down there, but that's okay. Okay, so that's R1. This is R2. The smaller one is R2. And we know that R2 times whatever that tension is, okay, equals the acceleration of this system, right? So that equals I alpha, the rotational acceleration, right? And then that equals, of course, 1/2 mr squared, right? And then, and that's R1, right? Because we're using the whole radius for the moment of inertia. So our r's actually don't neatly cancel out here, which is sad. It really is sad. Okay, and then that is times, so the substitution is, of course, I is 1/2 mr squared. And then I'm going to also substitute that alpha is A over R. We always do this, right? Okay, but it's A over R2. There we go. Okay, so now what I'm going to do is solve that for the t. Let's solve it for t. So t is equal to, well, if I multiply, if I divide both sides by R2, right, then I get 1/2 m1 R1 squared over R2 squared times A, right? Because I divided this by R2. When you divide, it's in the denominator, and so it's the r's don't cancel, right? Normally they would cancel if it was wrapped around the edge, but here they don't. Okay. And now let's solve for the whole thing. Let's look at this mass, right? We've got, let's do the linear acceleration, right? So we've got mg down and the tension up, right? Tension evidently is less than the weight. Okay, so I'm going to say mg minus t is ma. So here's our rotational acceleration expression. This is our linear one, right? So the protagonist is mg. The antagonist that's preventing the acceleration is the tension in the string. And that's ma. And now all we have to do is substitute. So I'm going to go mg minus 1/2 m r1 squared over r2 squared A equals ma. And we're almost there. Oh, did you see the mass cancels? Boom, Betty boom, Betty boom. Only one mass and they all cancel. Okay, so now I've got G equals 1/2 R1 squared over R2 squared A plus A. And then we can, of course, factor out an A. G is A outside of R1 squared over 2R2 squared plus 1. And A is equal to G divided by that, right? 1 plus R1 squared over R2 squared. 2 of those. And now we can just plug in numbers. 9.81 divided by 1 plus, and then this is 6.72. Notice they're both in centimeters, so that the ratio of them squared does not need to be converted. So it's 2 times 0.21. That's squared. That's squared. And this is going to be really small. The 1 is, this is a huge factor, right? Because let's just do this. All right. 9.81 divided by parentheses 1 plus 6.72 squared divided by 2 divided by 0.21 squared, right parentheses. And I get that the acceleration is 0.0191 meters per second squared. If I wanted to figure out the velocity after 1 meter, I could do that. Right, so that's going to be using v squared as u squared. That's 2as. V will be the square root of 2as, right? So square root of 2 times the number I just got times 1 meter, right? And the final velocity would be 0.19556 if we let it accelerate for a meter, right? Okay, now remember this expression. Remember that expression there, because I'm going to get that same expression using energy, right? And I'm not going to have to use a system of equations to do it, okay? I'll show you this. That's the next video.